Hello colleagues, today I will be talking about submaps, service zones and handover zones. More and more of our customers are building larger maps consisting more than one submap, and we would like to address the basics. We do have the detailed information in our operating manual, in our placement manual. Even we showed quite a few videos how to build those submaps. But let's start from the basics. What are the submaps? What are the handover zones? What are their service zones? Or what are they? So today I will have my cheat sheet, basically Q&A that we usually answer, but I wanted to address them one by one. So what is the map in general? Map consists of submaps. Submaps is a small cell which can consist of one beacon. If you want 1D submap, 2 beacons, and then you can have 2D submaps, or 3 or more, up to 4 stationary beacons in one submap. And this submap is a cell, like a cell in cellular network. Then if you want to build the larger maps, then you build additional submaps. So this submap would be, for example, covering this area, and another submap covering this area, and there would be 2 additional beacons, and then another submap covering this area. By default, each of the submap have some service area, service zone, as we call it. Service zone, if it's by default, it's 30 meters from the farthest beacons. So, for example, if you have the submap, 3D submap like this, so your default service zone would be up to 30 meters from this beacon, then up to 30 meters from this beacon, from this, etc. So it will be an overlapping of all 30-meter radiuses from each of these beacons. So the shape of the submap would be something like this, this, and this by default. Okay, maybe it doesn't seem well, but that's by default. It doesn't necessarily mean that's your optimal, because you may have another beacons, for example, in this area, and you don't want these beacons, or let's say these beacons serving this area, because you already have beacons in this. So this is why you shall specify the service zone for each of their submaps. For example, you had beacons here, 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 and you say, okay, my service zones for this submap would be this. So to each of the submap, you define the service zone. It's basically the zone which you tell the submap to serve. So this is your area of responsibility. This is your, I will trust, I means their navigation system. I will trust most of all, or let's say at all, in this area to you beacons. And for example, this is another submap consisting of the same beacons and 2 more new beacons. So these beacons belong to this submap and to this submap. And you say, okay, for you guys, this is my service zone. I will be trusting in this area only to you. In this area, I will be trusting and you and you. And this would be my handover zone. The handover zone is the zone where both service zones from previous submap and this submap are serving. And it's needed for the smooth handover. So it means that when the mobile beacon is moving from this until this zone, it's served only by this service zone and this submap. During this, it is allowed to be served and by this and by this. And the system is already making the decision, combining the data or still trusting this most or trusting this most. There are several types of the handovers. But in any case, it's a smooth handover, because in this zone, in their handover zone, the mobile beacon is traced by 2 submaps, by this submap and by this submap. And this is why you must have the handover zone. Even if you don't specify, the system will specify for you in any case, because in any case you will have the server zone. Simply sometimes when you specify them explicitly, it's much better. Because if you don't specify it explicitly, the system will say, make it huge, and this will be making huge, and there will be huge overlapping between the submaps, and the system will not know which one to use. It will try to select the right one, but doesn't necessarily would select the optimal, the best one. So for example, this beacon is very far from this area, but this area is still within 30 meters. You would be happily served, this dot in this area would be happily served by this because it's much closer, much better. But the system may try to serve by this beacon. Why? No, simply because you have not specified the server zone and you haven't specified the handover zone. So please do specify. About the number of beacons, you may have, as mentioned, for 1D submap, for example, a tunnel, you may have only one stationary beacon per submap. For 2D submaps, you may have up to 2 mobile beacons per submap. For 3D submap, you may have 1, 2, 3, or 4. You cannot have more than 4 station beacons per submap. In this case, if you have more station beacons, then build just another submap. It's done intentionally because 4 is sufficient for 3D. It's actually 3 plus 1 redundancy already. And let's talk about the redundancy. For example, very often you are facing the issue of obstructions and how to handle abstractions. Now, the best and the easiest way to handle abstractions is redundancy. So what do? You basically say, okay, this is my 2D map, and my service zone would be this. So I'm putting this on my wall. Okay, it's facing this direction, so I'm actually putting them like this. And then this is my service zone for this 2D. But I have a column here, or another column, or something like this. Wow. So it means that this would create a shadow in this area. Is it a problem? Yes, it would be a problem, because in this area you may expect interruption in the tracking. How to overcome it? Oh, wow. It's very easy. You do another submap, also 2D submap, and you specify the service zone for this submap exactly the same, but this direction. And notice there is a nose showing which direction it will be served. It's also here. So it means that you will have 2 completely overlapping submaps, and this submap is serving from this direction, and this submap is serving from this direction. What happens? In this case, the system will automatically choose which submap to use, because there are many algorithms how to select the right signal. And when you're in this zone, it will select a jump based on these coordinates, but it will select no jump based on previous historical data and based on some quality data of the signal. And then it will be using the data about the position from this direction. And that's not a problem. So it means that when you are here, this submap would be serving you. But when you are here, then this is shadow of the column. This will be serving you. So that's the overall logic. Use the fully overlapping submaps to serve when you have abstractions. In 3 plus 1 redundancy, it happens already automatically, because you need only 3 beacons for triliteration for 3D, but you have 4 beacons, and there are several triangles, and the system is automatically choosing the best one. It doesn't necessarily choose always the best one. This is why you still need to apply some intelligence, but still it tries to choose the best. Just a very short hint. You see, we are putting this kind of in the volume, in the plane. You cannot build, for example, a 3D submap by placing them like this, because you don't have the volume. Actually, you have only line. In this case, yes, you have 4 beacons, but no, you cannot build a 3D submap with placing station beacons like this. You must do it in some plane. Many questions ask, is it possible to put the beacons on the different heights? Yes, it's possible, station beacons, but always provide the height of these beacons. So they don't necessarily to be on the same ceiling. No, it can be on different heights, but you must provide the heights always. Particularly when you have their not on the plane, when on different height. When you have it on the plane, you may sometimes skip it, but in this case you will have a fixed Z error. What else? Today we support up to 250 beacons and up to 250 submaps. So it means that you can have, for example, a map consisting of 250 small submaps, and each submap is up to 30 meters. So it means that 30 meters, 250 times. So as you can see, you can cover a huge tunnel, or you can cover a very large warehouse, for example. That's sufficient volume. When you have two beacons in the submap, it would be automatically 2D. So you don't need to switch in this particular 2D mode or something. It would be automatically 2D. When you have 3 or more beacons, 3 or 4 in this case, it would be automatically 3D. But there is a special tick in the dashboard, so you can switch 3 or 4 beacons into 2D mode. But it's kind of already a bit more advanced. So usually it's much better to have either 2 beacons for 2D or 2 and 2 with the full overlapping submaps for 2D. Many questions are like, if we install more beacons, would it give more accuracy? No, it wouldn't give more accuracy, because if you have good coverage, then 2 beacons provide the same type of accuracy as 3 or 4 beacons. In fact, in many cases, 3 or 4 may provide even worse, because they will be kind of minority reports and minority opinions. No, it's much better to have sufficient. But what is better is their redundancy, or let's say resiliency against the obstructions. As mentioned, certainly 2 beacons will be more prone to obstructions than 4 beacons. But this is not 4 beacons, it's 2 plus 2 on different and overlapping submaps. So yes, if you have obstructions, please use 2 plus 2 beacons, not 4 beacons. Special cases. We do have 2D submaps, 1D submaps for tunnels. We have 3D submaps when you have the volume. For example, you have, copter flying. But we have also special cases. Those special cases are vertical. So sometimes, for example, when I have a warehouse, and inside the warehouse you have very narrow aisles, and very often it's simply inconvenient or a bit too costly to build. So this is your shelves. This is your shelves. I don't know, 12 meters height, just 3 meters here. Often, it doesn't matter where you are here in this Y direction. It is important where you are in X direction, and it's important where you're in Z direction. So it means that instead of building 3D submap with very narrow angles, and we have a particular video about that, please check YouTube channel. Sometimes it's convenient to build a 2D submap, but that would be not XY submap. No, that would be XZ submap, so-called vertical submap. And we have a description about this. So yes, it's possible. Sometimes it's convenient, not only about this case, but for example, you have a wall and have something flying. You don't need actually, you would be able even to provide 3D, but in this case it would be kind of vertical 3D. So think about this as, not X, Y, Z horizontal, but vertical, but from the side. So when you turn the pyramid 90 degrees, you would be able still to track X, Y, Z, and sometimes it's more convenient for various reasons. It really depends on your architecture. So about the service zones, as I mentioned, service zones are important. Service zones are there always. Specify you them or not specify, they are there. Simply, very often, it's not possible to build large maps without explicitly defining the service zones. Simply because if you don't do this, their system will do it for you, but not necessarily that would be optimal. So the very typical case, I have a large territory, I want to have a 2D coverage, how to build it? Well, fine. For example, I have a, I don't know, office, like, I don't know, 15 meters wide and 200 meters long. So you install the beacons up to, let's say, up to 20 meters. In this case, the maximum distance shall be still less than 30 meters. And that would be your service zone for this submap. Then I have another 20 meters, and I have another service zone, and I have another service zone, and so forth. So as mentioned, you can have up to 250 submaps, and up to 250 service zones, and so forth. About the handover zones, how large shall they be? Basic rule of thumb, 1 meter. You know, if you don't know anything, you don't have time, etc., do it around 1 meter. That would be okay. It's not too much. It's not too small. But where is this coming from? It's coming from two things. One is your update rate, location update rate, and another one, speed of your mobile object. For example, your mobile object is moving from this direction. And for example, your mobile object has 8 Hertz update rate. So it means that if you have 1 meter, during this 1 meter, you shall expect 8 location updates, which is great. Because in this case, it would be served 8 times in this area from this service, or from this submap and from this submap. And it would be a very smooth handover. If your object is moving, for example, faster than that, 2 meters per second, then you can expect only 4 location updates, which is still fine. But it's already less than 8. And for example, if you have not 8 Hertz, but only 4 Hertz update rate, then you would have only 2 location updates. And that's already critical, because you must have at least 1 or 2. They're the very minimum recommended location updates in the service, in the handover zone. Otherwise, the handover may be not smooth, and it may be hard handover. Not soft handover, but hard handover. Why? No, for example, something happened and you missed this one. And then you have only 1. But 1 may be not sufficient for the real-time player to make it smooth. No, don't risk it. So it means that if you have lower location updates or you have fast-moving objects, then you may have, you know, larger service zones, or wider handover zones. But it doesn't necessarily to be the best, because as mentioned, in this case, this beacon may be trying and officially entitled to serve in this FUD area, which is much better to be served this. So it means that you must have the service, the handover zone as wide as you need, but not more than that. Because otherwise, again, the tracking may be degraded. Not much, but still. A few words about other things, more complex things, but let me touch, because many people are asking in the same context. What is TDMA? What is it for? Since you are already building more complex submaps, and more complex maps, you may have 2 issues with those. One, which you need to take care the most, is of course obstructions. Because if you have obstructions, you don't see your satellites, means they're stationary beacons, then you may not have a proper tracking in the shadows. So this area would be not tracked, and this area wouldn't be tracked. I already mentioned full overlapped submaps, but sometimes you can do this not in the same time slot, for example, in EA, in inverse architecture, because they emit at the same time and serve in the same time. In NEA, you may try to use it in different time slots. So it means that in this location update, it's serving from this direction. In the next location update, it serves from this direction. It allows more robustness because the system is not forced to combine confidently wrong area with potentially good, confidently wrong data, because this is wrong data. It cannot serve, for example, here, we know it, but the system still doesn't know. But we try to combine this with potentially good data from this direction. The system will try, and in majority of cases will successfully combine this data, but doesn't necessarily will do in all the cases. So you may try to use TDMA mode. So it means that in time slot 1, this will be the serving submap, and the time slot 2, this will be the serving submap. And then what you will have to have this, and then this from this submap, it would be skipped, because instead of this, it would be somewhere here, and some jumps. So this will be lost, this will be lost, this will be lost, but this will be confidently okay. And then you apply the real-time player, which will be making a smooth thing, because it will be simply canceling these strange jumping locations when the TDMA gives this submap the serving time. So TDMA of full overlapped submaps are used when you have the abstractions. So it's served for abstractions. But that's only one of the needs for the TDMA. Another one is for inverse architecture. It's not used for non-inverse architecture, but for inverse architecture. As you know, in inverse architecture, we have only 5 frequencies currently: 19 kilohertz, 25 kilohertz, 31 kilohertz, 37 kilohertz, and 45. But when you build a large submap, you run out of combinations pretty quickly, especially when you have a complex warehouse with horizontal and vertical lanes and aisles, etc., etc. You run out pretty quickly of the options, and you cannot build a larger map anymore. So you have to move some of their submaps to one time slot and another to another time slot. It's kind of they live in 2 different times. So this submap is lived in this time, and this submap or submaps in this time. So they kind of coexist, but not at the same time. And it gives you freedom to build as large maps as you wish. Effectively, unlimited size of the maps. But it's kind of additional complexity, and of course there's a trade-off, because since it's TDMA, so it means that some time it's not served. So it means that if you have a regular 8 Hertz and TDMA of type 2, so it means that, or let's say not type 2, but 2 slots in TDMA, so it means that you will have location update of only 4 Hertz, because one is served in this, another one is served in this, so you lose some location update rate, but you enable another dimension. Thus, you can build a very, very large submap. Very, very large map, because you can build many, many submaps, and you are not anymore limited by the number of frequencies. The last words about how to build. We addressed this already several times, but since we are talking about pretty complex maps, the overall logic is very, very simple. Build simple things at once, achieve the perfect tracking in their submap. So let me basically spell it one by one. You want to build a large submap consisting of, or a large map consisting of 100 submaps. Build one submap. Define the service zones, achieve a perfect tracking in it. Send it to sleep, like really, send it to sleep. Then wake up this submap. Again, specify the service zone, achieve a perfect tracking in this area. Don't think that you have other, don't care. Just build this submap. As soon as I have 2 independently, perfectly working submaps, and tracking this is defined as well, then you are ready for the handover zone. So you build this handover zone already, but you wake up this beacon, and this beacon. You have 100 more beacons. Doesn't matter. You have only 3 beacons currently enabled, or let's say woken up. Use them, and you have a smooth tracking here because you already built. Then in this you may expect some jump because, for example, the submaps are not perfectly aligned to do something. Correct, because you can build a complex service zone with a complex handover zone, shape, etc. Adjust them, move them, maybe sometimes even adjust slightly the distances if the distances were not measured correctly, until you have a perfect smooth handover in this side. Then, exiting, and then from this direction. And you do these adjustments until you have a perfect smooth handover. That's it. You've done with 2 submaps. Once again, send them to sleep. Enable this one. Achieve the perfect tracking in this one, and make a smooth handover between these 2. Forget about them. And do this one by one until you build this first single submaps, then pair submaps, and then you kind of grow one by one, add one by one. Never jump over submaps. Never enable all the beacons and try to build huge map, not achieving a perfect tracking in each and single submap prior to that. If you do follow this, then it will be very easy to build large maps, because effectively you build small submaps and then you just adjust them and you make sure that it's smooth handover. That's very, very, very easy. If you try to build it, everything at once, then you will struggle because it's too complex. It's not clear why the problem comes from and where. Just don't do that. So again, submaps is a combination of beacons. Service zone is an property of each submap, which is specifying where this submap is serving. Handover zone is an overlapping between 2 adjusting service zones. Thank you very much.